All right, in this video we're going to take a look at how to decompose a function, or to write a function as a composition of other functions. In this case, our instructions are to take this function that we're looking at and write it as a composition of three different functions. So this process starts by, first of all, making the arrow diagram for the function that we have. Got a lot going on, so I'm going to start over to the side and write a little smaller than I have been doing some of these other ones. So the first step is to subtract pi over 6 from both sides. That doesn't look quite like I want it to. Let me try that again. And then that needs to go inside of the sign. This is an order of operations thing here that will reveal whether your kids recognize that sine cubed is, first of all, taking the sign and then cubing. We need to change the sign on that, the SIGN sign, to get the negative sign cubed. And then we will add 4. After adding 4, we then take the square root. After taking the square root, we will divide by 9. We need to then change the sign again, and then finally add 3. So that gives us a lot of things that are going on. This should be the arrow diagram for the function as it exists right there. And with the arrow diagram, the decomposition just becomes a matter of choosing where I want to make the breaks on my function. So I could, for example, say I'm going to make one break there, and I'll make one right here. And so that splits this into 3 pieces. And what I can do for this first part, I start it with the x as it is. My first function then has to be the one on the inside. So these 2 arrows together will make the function m. And these 1, 2, 3, 4 arrows together will make the function f. That was the next one that's in there. And finally, the last 3 arrows together will make our function g. So what does m of x look like? Well, m of x, we start with an x. We get a x minus pi over 6, and then that gets put into a sign, and that stops. And then we start over with a new x at this point to get an idea of what f of x looks like. And so it's got an x that's being cubed, sign change, add 4, put it under a square root. This is our f of x. And then finally at the end here, we fire a new x in there again, and I get an x over 9, change the sign, add 3. This is g of x. So there is one way to decompose this function into 3 different functions, such that h of x is equal to g of f of m of x. Okay. Now, that's not the only way we could do this. Let me move some of this stuff out of the way here. Put that together, shrink that down a little bit. We'll just kind of keep that one up there, and probably move these out of our way for the time being. And we could make our breaks in different places. So maybe I run the m function all the way to there, and then I'll throw in the next 2 arrows there. So I'll make m this function represented by those 3 arrows this time, and I'll make my next function on the inside, which is the f, represented by those, and then I'll throw the last 4 arrows together and make that g. So what does m look like? Well, we start here with the x, and we get x minus pi over 6, and add the sign of that, and then cube it. So that's our m of x. We start with the green one. We locate an x in there again. This time we have negative x and we add 4. So this is our f of x, is 4 minus x. And for our last one, we load an x in here, and it says start with the x, take a square root, divide by 9, change the sign, add 3, and that becomes our g of x. Okay. So in this process, you can see that you can choose to split this big arrow diagram up any way that you want into as many pieces as you want. We have, what do we have, 3, 4, 5, 6, 7, 8, 9 arrows here. So I could have split this into a composition of 9 functions if we wanted to do that, or any combination, anything less than 9, we could split this up and show how this is a composition of lots of different types of functions.